Now let's just see the next, which is an important topic which is all related with this particular chapter, which is nothing but called as the surface area of a right circular cone. But before that, let us suppose if I'm just recalling the figures that we have already done with, means we already know that how we have obtained a particular cuboid, or if I'm just talking about this particular cylinder, that how we have actually obtained it. We have obtained it by stacking up them in a particular vertical pile. As you can see, these solids which are obtained by stacking the congruent figures, they are basically called as prisms. So whenever we have obtained such type of the figures which are actually obtained by a particular figure, and we have just stacked them up in a vertical pile and obtained the solid figure, such kind of figures are incidentally called as nothing but prisms. Now we are just going to talk about next type of a solid figure, which is not a prism but it is called as a pyramid. So let us suppose if I am just talking about this particular triangle over here. So as you can see, this is nothing but a triangle, and I have just taken a string which is along with it, and I'm just revolving this string which is attached to this particular triangle, and I'm just rotating it in such a manner. So if I'll just rotate it along the string which is attached to this particular triangle, the figure so formed should be nothing but of this form. As you can see, this would be the figure that would be formed if I'll rotate the string in such a direction. This would be the figure that would be obtained, and such type of a figure is definitely called as a right circular cone, because you can see over here that this string is actually at an angle of 90 degree with the base of this particular cone. With the base of this particular cone, this string is forming an angle of 90 degree, and that's why it is nothing but called as a right circular cone, because there is a right angle which is formed at the base of this particular cone. So let us suppose if I'm just talking about the specifications. So if this is nothing but a cone, so this radius at the end, means the base radius is this is nothing but called as the radius of the base, which is represented as small r. The height of this is nothing but as this. You can see the string that we have in between the center is representing the height, and this particular height is nothing but called as the slant height. So in general, basically we have the three things over here: the base radius, the height, and the slant height. These are the three things that we have now in a right circular cone. Now let's just move on further. If I'm just talking about this particular right circular cone, so we know that there are three things which are related with this particular cone. One is the base radius, which is represented as small r. One is the height, which is always represented by small h, and the other one is the slant height. So we actually represent the slant height with L. So L is nothing but called as the slant height. So let us suppose if I'm just talking about the curved surface area of the cone. So the curved surface area of the cone should be nothing but it's just same as that of the area of the triangle, because at the start we have actually started with a triangle only, and when we have just rotated it along the string, we have generated a right circular cone. So it means that the curved surface area of the cone should be is equal to the sum of all the triangles that we will get at the end. So hence this would be nothing but of the form half into L into the circumference of the base of the cone, and we know that the circumference of the base of the cone is nothing but a circle, which is nothing but 2 pi r. So hence at the end we have calculated it as nothing but pi r L, where L is nothing but a slant height, and there is a relationship in between the L, B and H, which is nothing but L square is equal to B square plus H square, and we will also talk about this relationship furthermore and we will also derive it, but for this time only we are just taking it as L square is equal to B square plus H square. This is the relationship in between the L and the R and the H. So basically in place of B we have over here as nothing but R. So B we are taking as nothing but R over here. This B, let us suppose if I'll write it over here, where B is nothing but is equal to R, which is nothing but is equal to the radius, which is nothing but is equal to the radius. Now let us suppose if I'm just talking about this, so if I just have to write the radius over here, so this would be L square is equal to R square plus H square, and this is the relation that you always have to remember, that slant height is always is equal to R square plus H square. So how we have actually calculated this? Let us suppose if I'm just talking about the half section of this particular cone, and I'm just taking the triangle only. So since we know that we are just taking this as L, and we are taking this as nothing but R, and we are taking this as nothing but H, and we know that it is a right circular cone, means it is forming up a 90-degree at the base. So hence we can see that here the triangle which is so formed is nothing but a right angled triangle, and we know that hypotenuse square is always is equal to perpendicular square plus base square. So hypotenuse square means L square is nothing but is equal to perpendicular, which is H square, plus B, which is nothing but R square. So hence L square is definitely coming out to be is equal to H square plus R square, and this is exactly what I have written over here, that in between LHR there is a relationship that L square is always is equal to R square plus of H square. This is nothing but called as the curved surface area of the cone, which is nothing but is equal to pi RL. So let us suppose if I'm just talking about the total surface area, what would be the total surface area? So the total surface area of the cone should be is equal to the curved surface area, should be is equal to the curved surface area plus the area of the base. It is quite an easy thing to see, because if we are just talking about a cone, there are two things in a cone. One is the curved surface area. The curved surface area is nothing but this portion is nothing but called as the curved surface area, and the other area is nothing but the base area. So if we are just talking about the total surface area, this should definitely be the sum of the curved surface area plus area of the base, and since we know that the area of the base is nothing but the area of the circle, so this would be nothing but pi RL plus pi R square, because the radius of the base is nothing but small r. So hence let us suppose if I'm just taking the things common out of it, so this would be pi RL plus R. This is nothing but called as the total surface area. This is called as the total surface area of the right circular cone. So always remember, the curved surface area of the cone is nothing but pi RL, where the total surface area is nothing but pi RL plus R, where L square is nothing but is equal to R square plus H square. So this is all about the surface area of a right circular cone.